Alright, in this video I'm going to do a couple examples of solving logarithmic equations, and anytime you solve logarithmic equations, once you get your answers, you always have to go back and check for extraneous solutions. Remember, we can't take logarithms of any non-positive number, so this is something you just have to worry about at the end. So in A here, we're going to solve 2 times log base 3 of x minus log base 3 of x plus 6 equals 1. The first thing I'm going to try to do on the left side is rewrite this all as a single logarithm. So I can rewrite 2 times log base 3 of x as log base 3 of x squared. We can move the coefficient up as an exponent. I'm not going to do anything with my second term here. But remember, if we have like bases, if we have subtraction, this becomes division. So we'll have log base 3 of x squared over x plus 6. That equals 1. And now what I'm going to do is just rewrite this using properties of exponents. So it says 3 to the first would equal x squared over x plus 6. So okay, now we've gotten rid of the logarithms. And now I'm just going to multiply both sides by x plus 6. On the left side, we would have to distribute our positive 3. That would give us 3x plus 18 equals x squared on the right. And now this is a quadratic. I'm going to make the left side 0 by subtracting 3x from both sides and by subtracting 18 from both sides. And I think this is a quadratic that's going to factor. So I believe this factors as, how about x minus 6 and x plus 3. That looks okay. So if we set each factor equal to 0, we'll get our solutions, our potential solutions, to be x equals 6 and x equals negative 3. Now let's go back and look at the original problem. We were trying to solve 2 times log base 3 of x minus log base 3 of x plus 6. I kind of check. Notice if we put in the value 6, we'll get a 6 here, which is fine. I'll get a logarithm of a positive number. If I plug 6 into the other logarithm, I'm going to get a logarithm of a positive number. And so far, so good. And you can check that if you plug 6 in, this is going to work. But notice if we plug negative 3 in, we're going to have a logarithm of a negative number. On the second term, we would end up still, if we plug in negative 3, we would have positive 3. But on the first part, we would end up with 2 times log base 3 of negative 3 minus some other stuff. But already, because we have this negative inside of a logarithm, that is bad. And that means x equals negative 3 is what's called an extraneous solution. So x equals 6 would be our only solution in this problem.